Welcome, everyone, to our webinar, Service Identity, the Key to Zero Trust with HashiCorp Consul and Vault. I am Ashar Sayed, Product Marketing Manager for Consul. I am joined by Blake Kovar-BS, Product Manager for Consul, and then David Yu, who's also Product Manager on Consul and Kubernetes. So let's see the agenda for today. So we have an exciting agenda for today. We'll cover some of the security challenges that exist today and how the environment is changing and what are the ways we can address them. And zero trust is one of the ways. And what exactly is zero trust? So we'll discuss that as well. And where does Consul fit in that zero trust model in terms of application networking, securing that application networking and environments between microservices that you have. We'll also cover some of the enhanced security workflows that we have had between Consul and Kubernetes and Vault integrations towards improving your security posture. And then we'll go into a demo with Consul and Vault, and we'll leave some time in the end for Q&A. So with that, I'll hand it over to Blake. Blake, take it away.
Oh, thank you, Usher. So just to set some context real quick before we dive into the presentation, I wanted to kind of discuss the security challenges that are faced by organizations today. And so the first is that a lot of organizations are undergoing this shift from traditional data centers that have they're relatively static and use IP address as a source of identity and traditional perimeter-based security to protect that environment, over to more modern data center environments that have many more applications that use dynamic IP addresses. And often these applications are deployed across multiple cloud and multiple runtime environments. Or these apps need to communicate with other applications that are across different clouds. And so in this more modern data center, there are no clear network perimeters. And this really presents challenges for operations teams that are tasked with securing these environments. And so these challenges then translate. Oh, I don't think the slide advanced. Are you? Just 1 minute. Let's try that again. Okay.
Good. Go ahead, very good.
Sorry, I was seeing a different thing on my side. Can you confirm what side you're seeing, Usher?
Yeah, we're seeing the 10.5 trillion.
Okay, great. So these challenges then translate into increased risk for the business, and to kind of understand why U.S. CEOs place cybersecurity as their #1 worry is, according to a report by Cybersecurity Ventures, there were $6 trillion worth of losses in 2021 related to cybercrime. These costs were incurred or related to the destruction of data, stolen money, lost productivity, or even the theft of intellectual property, to name a few. Cybersecurity Ventures estimates that these figures will continue to increase by 15% year over year for the next 5 years, ultimately reaching 10.5 trillion in 2025. And kind of related to that, a study from IBM found that 90% of cyber attacks that happen involved lateral movement within the data center. And this means that an attacker compromised one component or application within the data center and then use that to gain further access to the environment. And so in these type of attack scenarios, traditional perimeter-based security really isn't sufficient to protect these modern data centers. And so how can Zero Trust help with these challenges? Well, first, let's define what Zero Trust security means. In a nutshell, it means that applications should trust nothing and authenticate and authorize everything. And so if we break that down a little more, that means that security should really be based off of service identity, not based off of IP addresses. Services should mutually authenticate those identities when establishing connections to other applications in the environment. The service's identity, and again, not IP, should also be used for making authorization decisions. The access credentials that are delivered or given to services should also be time-bound, so that the user or the application needs to refresh those credentials at a common interval, or sorry, a defined interval, so that you don't have long-lived credentials in the environment. Also, data should be encrypted in transit, so that you're not sending anything that is unprotected over the wire. And lastly, all of the access attempts should be logged and audited, so that security teams have visibility into the communication that's happening within their data centers. And so within the HashiCorp cloud platform, Vault is really that central foundation for securing secrets across these different data center environments. It provides a central store for storing secrets, and as well as allowing applications to use Vault to encrypt data within the environment. So applications don't need to manage their own encryption keys or handle passing those around in order to unencrypt that data. They can request that Vault encrypt that data, and then Vault is that central source for managing that and the access to that data across these different clouds. At its core, Vault's guiding principle is identity brokering. And so what this provides is the ability for applications to use different credentials depending on what cloud or runtime environment they're running on, authenticate with platform or those platform-specific credentials into Vault, and then Vault maps that into a single identity that can be used to enforce a common policy for applications across these different cloud environments. And so now, kind of switching gears a little bit, what is Consul? So Consul is HashiCorp's service networking platform that enables service communication across multiple cloud and runtime environments. It provides a number of capabilities. The first is a service discovery and health monitoring. And what this is the ability for you to register services deployed across your environment into a catalog that then can be used by other applications to discover and connect to other applications across your data center or cloud environments. Consul keeps track of the health and availability of these applications so that applications are always routed to available endpoints. The other functionality it provides is service mesh. And what this gives you is a way to consistently encrypt and authorize service-to-service communication across different clouds or runtimes, as well as observability for that traffic between those environments, and a resilience for application traffic by allowing you to implement things like connection retries or connection limits within the service mesh, and not having to delegate that or into the application logic itself. At its core, the service mesh uses the service identity as the basis for all authentication. Consul also supports something called network infrastructure automation. And this is really focused on allowing operators to reduce the time to deploy applications and kind of eliminate manual processes by allowing you to automate day two networking tasks using Terraform. And then lastly, Consul provides an API gateway that's really focused on enabling north-south communication for external clients that are ingressing and need to access services within your data center. And so for the purpose of today's presentation, though, we're going to focus on this secure pillar with service mesh. And stepping back a little bit more, where Consul fits in within HashiCorp's product portfolio is Consul is the solution or zero trust solution that's focused on machine-to-machine access and communication. And so, I talked about some of the benefits in the previous slide, that it's providing encrypted communication and using service identity as that basis of authorization between those between applications. And so how can Consul and Vault help an organization improve its security posture? Typically, they can be used in kind of a model like this, right? Organizations will often start with adopting Vault and using that as a central store to protect their secrets. And then they'll graduate to using more of Vault's dynamic credentials capabilities, which is the ability for Vault to dynamically provision short-lived credentials that can be given to an application when it is trying to access some destination, and then revoke those when those credentials are no longer needed. As organizations then adopt something like Consul Service Mesh, they start securing that communication using service identity. And then Vault and Consul together are providing encryption for all of the data and communication within the environment. And again, Consul is used to authenticate and authorize all of the network communication. And then lastly, Vault provides multi-factor authentication where getting access to Vault can be secured not just by one secret, but multiple secrets to kind of provide defense in depth for that system. And so what we want to talk about today is Consul 1.12 and some of the enhancements and work that we've done to tighten the zero trust security story and with Consul and Vault to better integrate those together. What David's going to be talking about in a little more detail is this integration that simplifies secret management for Consul running on Kubernetes by using Vault as that central store for PKI certificates and secrets that Consul uses for its communication. And then also we're going to talk in more detail about how this integration is used to provide automatic certificate rotation for these certs used by Consul, again, centrally storing these within Vault. And so the benefits of this integration is that this strengthens or improves the zero trust security posture for Consul on Kubernetes. Consul's no longer storing or some of the sensitive information within Kubernetes secrets, which are really just base64 encoded blobs. They're not encrypted within the Kubernetes data store. But now these are delegated to this, Vault as an external store, and Vault is providing a central place that an organization can not only store the secrets, but then audit access to those across these applications, Consul included. And so with that, I'm going to pause and actually hand things over to David to talk about the integration in more detail.
Thank you, Blake. Hey everyone, this is David, product manager for Consul and Kubernetes. And let's go ahead and dive a little deeper into the integration that we built with the Vault Secrets backend. Also talking about some of the enhancements and then go into a quick demo. So let's recap what we did with Consul 1.11. For those of you that have been following Consul, we initially started this journey of integrating Consul and Kubernetes with Vault, starting with our previous release. What we did was we allowed you to generate the server TLS cert using the Vault PKI engine, and also expose the ability to leverage Vault PKI to generate client certs as well for the client agents in a specific stanza that we built called the secrets backend stanza in the Helm chart. As you know, we have always traditionally been providing you the ability to also generate and reissue the certificates for the sidecar proxies on the data plane. That's always been available to you, but we made it a little bit more friendly so they can leverage that within the Helm chart. Now, when it comes to making sure that communication is secure, we have an additional key called a gossip encryption key. So the clients and the servers are essentially Consul agents, and they communicate over RPC. There's a specific encryption key for encrypting that traffic that we have to leverage, and we now can retrieve that key from Vault. Also, the enterprise license key for those of you that are leveraging enterprise features like admin partitions or audit logs. You can leverage that license key within Vault as well. HTTP Consul has always been available to our practitioners and our customers, and you could leverage HTTP Consul with HTTP Vault as a Connect CA, which essentially allows you to generate the MTLS certs for the proxies that are running on your data plane, whether it be running on EKS or on a VM, specifically to Amazon. If you are interested in also leveraging this with Azure, we have an upcoming beta that I would definitely keep your eye out for. So with that release, we definitely had some other additional enhancements you wanted to get to that we'll talk about in a bit, but specifically the enhancements that were not included were the ability to rotate the server TLS certs automatically. there is a feature where you can federate console data centers in Kubernetes across multiple regions, and we call that WAN federation. So that was not supported. Also, our ACL tokens are still leveraging kube secrets, and admin partitions was not supported yet for the Vault secrets backend. Now, so let's talk about what that really meant from a perspective of an operator, right? So if you're using Kubernetes secrets, right, with your service mesh, which every service mesh does today, with the exception of console, you basically are storing your secrets in a non-encrypted format, which is base 64. Now, those secrets also do not have a TTL, so technically you don't know when they expire, whether they're old and they have been compromised. Also, the secrets themselves are just within the cluster boundary. So if you're managing multiple queue clusters, this can be an operational challenge. So the benefits of using Vault, right, for storing these secrets, whether it be the service mesh infrastructure secrets or certificates that are provisioned by a PKI engine like Vault, leveraging something like Vault allows you to essentially manage all this, and allows you to encrypt all the underlying secrets and leverage it across multiple clusters. We do have a TTL associated with these secrets so that you can actually make sure that they do get rotated and refreshed when needed. If you were to just kind of expand this like into a diagram where you have all these cube clusters and then you have your secrets managed before on each cube cluster, this is what it would look like if you were integrated into Vault, right? You can have multiple cube clusters that talk specifically to Vault and store all the secrets. And then you could leverage Vault for authorization, and also you can use it for identity to get those secrets and retrieve it back for your service mesh. Another thing that's interesting, right? So in most service meshes, and console is a service mesh, we have the ability to manage the control plane, which basically allows you to then manage the underlying data plane, which is more likely the proxies. Now that control plane needs to be secured. So that means you have to have certificates that, basically expose or encrypt the traffic to those APIs that are on the control plane. What we've seen is that, operators, they typically don't want to rotate things manually. And when it does become an issue, is usually they forget, to rotate a specific certificate, and then things just don't work anymore. So automatic rotation is a really big thing. And that's something that we built into the server TLS issuing and rotation. And that's something that Vault provides us with. So it reduces that operational burden, and we can secure the underlying control plane and make sure that's secure, as well as the data plane as well. So I wanted to talk a little bit more about some of the core enhancements we made to console. Console is, we have an API. The core API has been actually enhanced to make sure that we provide a really good experience for our users of console, as well as console and Kubernetes, to ensure that access control lists are managed in a way that's user friendly. And typically the reason why you need to deal with access control lists, or we call them ACLs, is because you want to secure communication to APIs. So you typically have something called an ACL token. That ACL token is used to talk to an API. If that ACL token does not have a privilege or the right roles and policies associated with that ACL token to make that API call, it would get something like this, right? Permission denied. So what does this really mean? For somebody that sees this log, it's really, really tricky to understand why this particular log file existed. What we wanted to do is actually make it even simpler for somebody to troubleshoot what's going on here. So in this case, what we're doing is we're showing the ACL token accessor ID, and we're showing you why it did not work, right? What partition it ran in, and also what namespace it ran in. One of the things that you'll notice is that you can actually go ahead and read ACL tokens if you have the right privilege to do so, obviously, and you've already authenticated the console. But in this case, you can see when you read the token, you can see the policies now associated with the ACL token. And then there's another flag called expanded, And what that does is it shows you every policy and also the roles that are associated with a specific policy. And typically what happens is some of these policies are inherited, right? Either by your namespace or the global defaults. And most people don't know about them until you see the actual hierarchy. And so being able to see that in a single command is very useful. Cool. So I'm going to switch gears here and show you a quick demo. I'm going to show you a demo of our specific Vault integration. And just give me 1 second here. So this is actually recording, and I wanted to do it as recording because it takes a little bit of setup, but this is essentially what we're trying to actually show you in the architectural view. Where in one data center, you have Consul and Kubernetes running. You also have the Vault server running as well that houses the Vault APIs. And on the other data center, we actually have it federated to DC1, and we're running the agent injector to retrieve the secrets from the Vault server itself. So this is a federated setup with the Vault secrets backend implemented, and we're using that to retrieve all the secrets associated with Consul. So you can do this in any cloud provider. This is specifically Azure that we're showing you here. But what you can do is you can actually go ahead and set up 2 kube clusters as an example. It could be more if you wanted to. And you can go ahead and deploy Vault first to basically deploy the server. This is a dev instance of Vault. We're using a load balancer to expose the UI as well as the APIs. And we're using Kubernetes auth, right? We're enabling that and using that with the injector. So we'll go ahead and install this using a simple hello command. Vault can be installed in Kubernetes, and you can easily do that. And once you have that set up, you have something like this, right? On the left-hand side, you've got a Vault server running. Nothing else set up yet, but this is what we're starting with. You can easily look at if you've never done this before, when you run it, you can just look at the pods. You can look at the services. You can see the servers running, the agent injectors there. There's also underlying external IP that's associated with the server. Now we're going to use that specifically to validate how these secrets are actually, where they're stored and if they are indeed stored within Vault. Vault has a UI. You can log in with a token. You can log in MFA, right, with defense in depth. And then you could see as those secrets get generated, where they live and how they're secured. Now what we'll do is actually go ahead and set up an additional Vault client server where we just deploy the actual agent injector, and then go ahead and just reference back to the Vault server via the external adder config stanza. And that will just set up the actual agent injector, right? So we're just getting the scaffolding in place so that the secrets backend is basically up and running. Cool. So just a quick view of the actual DC2. So this part is important. So we scripted this, but essentially what we're doing here behind the scenes is basically setting up Kubernetes auth, the auth method, actually creating roles and also policies associated with Vault so that Consul and Kubernetes can leverage Vault as a secret backend, right? So this is the auth method that we're enabling inside of Kube. We're actually going to leverage that to retrieve, authenticate the Vault and retrieve the actual secrets. And then we also need the associated authentication roles and policies that actually are leveraged with Vault that our Consul and Kubernetes components use. And then we'll actually go ahead and start to install Consul and Kubernetes on top of these roles and policies, and then start to access those secrets as needed. The PKI engine is something we enable as well. So that allows us to generate certs, right, for the servers, the clients, and the sidecars. And then there's an additional sets of policies that you'll need to leverage the Vault as a CA for the certs. Cool. So going back to the UI, we'll see some additional secrets engines pop up here. There's a KV2 secrets engine. There's a PKI secrets engine. There's Consul, the secrets that we're using to store within Consul. You notice here, we actually generated a gossip encryption key using the Consul CLI command. And there's also a replication token, which is used when you're doing WAN federation. PKI is again leveraged for securing the agents. So the agents for the servers, the agents for the clients, and then we can actually validate that by looking at the certs themselves later on. So this is actually where we deploy Consul. And when you're using Consul and Kubernetes with Vault, there's a new stanza called Secrets Backend that allows you to actually specify Vault as a CA, and you can leverage all the APIs that are leveraged there. And we can essentially go ahead and install Vault, right? Consul and Kubernetes using a Helm command. And then that should bring up all the things that we need to basically run an entire Consul cluster, or we call it a data center, if you will. And this is that YAML file that describes how we build it up. We'll take a really quick peek. If you never deploy Consul on Kubernetes, when you deploy, this is what it looks like. You can see the underlying pods. You can see the server there. You can see also how the Vault server still exists. And then we can go in to the UI of Vault. Once we log in, we could see additional. You can see now the Connect CA now to show up. This is specifically related to how we actually provision the server mesh certificates, and then how those certificates then get issued to the sidecar proxies, right? So Vault is now the Connect CA. It's essentially the CA that generates those sidecar certificates. And then we can see also how that's been utilized to, basically secure other things like the clients themselves. So here we're just validating some the intermediate cert and the root certificate for the Connect CA, and then we're gonna just validate that exists, and that's identical to what we see when we're actually inside of the pod itself, the pod that's running the servers. We can go ahead and validate that against what's already inside of Vault. So this is really important, right? Just being able to make sure that the underlying secrets are in Vault are being leveraged for the service mesh and are being leveraged for the service mesh infrastructure. And in this case, now we can also dive into the actual certificates that are provisioned for the other agents that are inside of the actual Consul cluster. So I'm gonna really quickly skip over some of these validations that we're doing here, but I want to talk about specifically what happens in a WAN federated environment. So let's go ahead and skip towards that piece. I apologize for the skipping. Okay, we'll talk about what happens so in this case, what we're trying to do now in the first data center is go ahead and get what's called the external IP of a mesh gateway. And we're also looking at the actual Vault server. And so we need that to actually construct what's known as the secondary Consul data center. The secondary Consul data center needs to connect back to that data center over the mesh gateway IP. And we also need to point back to the original Vault server that we need to authenticate to retrieve those secrets. Now, again, we're using 2 KUBE clusters. We're using single Vault secrets backend. We're deploying the additional Consul data center that's used to federate to it. And this is a demonstration of how when you're deploying that, you're leveraging Vault as the entire secrets backend for 2 KUBE clusters. You can easily do that, and we're sharing secrets for specific use cases like the bootstrap token as well as the replication token. And then the additional secrets that are generated for that data center are also stored in Vault as well, specific to the certs that are generated for the clients on that data center. I'm going to stop here because a lot of this demo here just kind of validates that the actual certificates are there, and you can see that it's in Vault, and then it's also running within Consul and Kubernetes. But I highly encourage you to take a look and go and check it out yourself. Let me go back to the presentation. Give me 1 second here. Cool. And so I wanted to quickly recap what we discussed, right? So we talked about how we can leverage, Vault and Consul and Kubernetes and Consul in general to deploy a consistent security model across all these services. We're authenticating, we have identity, we're making sure that the traffic's encrypted, leveraging all those principles of zero trust to enable that to enable the security model across multiple clouds and multiple runtimes. We recommend that you use HashiCorp Consul and Vault together as you start your journey with zero trust because it provides a foundation for your services that run across your different runtimes. As you saw today, it's pretty simple to set up. It allows you to leverage all the principles that we talked about and run this securely. So with that, I'm also going to give you some resources here on this slide. There is a release blog that came out with a 112 release. We do have a working example of what I just demonstrated. So if you're interested, you can go to that GitHub project. You can see the contents of the YAMLs, the actual script. And our documentation also walks you very quickly through what that looks like. And thank you for your time. I hope you enjoyed the presentation as well as the demo. I'll hand it off for any questions that you may have.
We'll give a few minutes for questions if there are any. You can either comment or Linda, would we be able to allow them to unmute as well, or? Okay, got it. Okay, so yeah, so just post your questions in the Q&A section.
Yeah, so there's a question here about what does architecture look like with a DR instance of Vault. So Vault has two different types of replication. There's a performance replication and a DR replication. So in terms of a setup where you would leverage Consul and Kubernetes, you would need to ensure that across multiple regions, you would need to ensure that there's a performance replica available so that that replica is where the secrets get replicated to, where the Consul and Kubernetes servers live, right? So yeah, that central primary Vault cluster that has all these replicas that it communicates with. That performance replica is where you actually go ahead and store secrets to from Consul Kubernetes, and then the DR replica would then basically like back up that performance replica. If you've seen the diagram of Vault and how that's deployed, and that would be how you do that.
So there's another question about the Consul backend and whether that's still recommended for Vault. The Vault team actually introduced an integrated storage option in Vault 1.4, I believe, and that is the recommended deployment model if customers are maybe if you're looking for a simplified deployment for Vault where you don't want to create an extra dependency by having to run, and secure Consul. So you can use Vault as Consul as a backend for Vault. But again, if you're just looking for something more simple, the integrated storage option is the way to go.
Yeah, I saw a question about can a zero trust service be exposed to a network? It sounds like continuous mutual auth effectively prevents using exposed service, but it's still exposed, right? So yeah, I mean, in terms of services, like inside of Kubernetes, there's multiple ways to expose a service. You could expose it just to the cluster using a cluster IP, or you can expose it to like the world using a load balancer, right? You would probably prefer to first expose it within the cluster itself, only if you need to. And as far as like how you communicate across multiple kube clusters, that's why we have the federation capabilities built into Consul and Kubernetes, so that we can actually leverage when federation to talk to the other kube cluster without having to expose that service, right? So we're using the service mesh itself to actually authenticate and also authorize the actual traffic from one kube cluster to another.
Yeah, and
Blake,
I'll
did you
add to
have?
that a little bit.
Yeah.
Yeah, sure. So Consul also provides two different ways that you can allow external traffic into your service mesh. One of them is by using something called an ingress gateway, and basically this is a proxy that sits on the edge of your service mesh that allows connections in from external sources or external users, typically within your data center, though. And so they could those services do not need to use mutual TLS when talking to the ingress gateway. They can just use one-way TLS to secure that communication, and then the ingress will route the connections into the service within the service mesh. The other option that Consul has is using the API gateway, which is a relatively new offering, but that performs a similar function, sitting on the edge and providing that ingress point for your services.
I'll take the next question about does HA Vault set up in this type of system across federated clusters? Do you have to set up HA Vault? So the answer is we can actually point directly to a separate Vault cluster that's set up for you. You know, obviously with its own operational policies, right? So we have the ability to talk to the external Vault cluster using the Vault API adder stanza. And so it doesn't have to run on the same kube cluster. We did that for the demo just for simplicity purposes, but you could just talk to a cluster outside of where your Consul server is.
And David, there's another question. It says, isn't Vault just another perimeter around secrets?
Oh, is Vault a perimeter just around secrets? Yeah, so Vault does provide a lot of capabilities, but yes, it can provide that perimeter for your secrets, but it can do so in many different ways. It has many different ways it can also create that perimeter. It has its own namespace construct within Vault, so that you can only authorize people that have access to a certain namespace to access the secrets that are in that Vault namespace, for example. But you can just replace what's in Kubernetes with using a secrets backend like Vault if you're using Kubernetes for your workloads.
Blake, you were going to take the next one?
There are actually a couple that were related to the integration. David, are you also able to take those as well?
Yeah. So there was a question from someone about being able to replace the secrets backend for Kubernetes. Can it store multiple kube cluster secrets they have connected to my Vault instance? Yeah, I don't know if that question is related to Consul, but essentially Vault can be your secret store for whatever use case you're thinking about. In this case, we're talking about service mesh and securing service mesh infrastructure. And so it can definitely be leveraged for other use cases that you have specifically for Kubernetes. And you can use a Vault agent, right, to retrieve those secrets. Granted, you have the right access to, like you've authenticated, and also you have the right policy to access them. Does Consul use an operator framework to accomplish things like cert rotation? So we do use the operator framework. It's built into our control plane. But as far as cert rotation is concerned, what we're doing is our servers actually have the ability to watch whether a new certificate is provided to the server, and then pick that up automatically. So that's built into Consul core, the cert rotation mechanism. We enable that through a flag that we run the servers with. But in general, yes, we do use an operator framework, but it's not used for that specific use case. We will be leveraging it for more things in the future.
I guess I could take this other one. The question was, what we demoed today mainly showed AWS and partially on Azure, but does this also support GCP? The answer is yes. This integration can be used across any of the Kubernetes distributions that are supported by Consul, and Consul does have support for GKE as one of those distros.
Thank you for your questions. These are great questions. I appreciate you all chiming in.
So any other questions from the attendees?
See a few
Okay,
more.
here we go. We got some more. Thank you. So the first one is about supporting TTLs and lease. Does it support secret auto rotation renewal? Yeah. So Vault does support that use case now. Rotating specific secrets all have its own separate mechanism for rotating them. What we do today is we rotate the server certificates, which we consider a secret, and we also rotate the client certificates as well. The other secrets that Consul uses, like ACL tokens, what we actually wanted to do was instead of actually rotating them, we wanted to instead perform what's called a Consul login via the Kubernetes auth method, and that allows us to get the right permissions to do API calls and also retrieve an ACL token for temporary use. And we thought that was a better model for that specific use case. But yes, we can leverage Vault in the future for also supporting additional secrets that need to be renewed using a TTL on lease. Would you mind sharing the resources we use today? Yes, we will. There's a HashiCorp repo that actually goes through the demo that I showed you from its entirety. It walks you through the exact config, how to use Vault and set it up correctly. And it has nice diagrams of how this is set up.
I can take the next one.
Yeah, go for it.
Sure, yeah. So the question was, is it generally true that the federation links between clusters are secure enough with MTLS, or do you need to use some other solution like a VPN or other tunnel? I would say that what we recommend is a more kind of defense in depth security strategy. So while Consul does provide encryption for communications between the different gateways, that's just one layer of security. It's still important that you protect access to those gateways and make sure that, or you control access to those gateways. And so you would want to deploy things like, security groups on the instances where those are running to make sure that only trusted endpoints can access those gateways. If you want other security, or if you have, say, existing direct connect infrastructure, we would definitely recommend using that over routing these connections over the public internet.
There was a question about whether we showed everything today that was all enterprise only, or was it OSS? So to answer that question, most of the things that we highlighted in the demo were OSS. So you can try it out today without an enterprise license. However, if you want to scale that out, the deployment out, there are enterprise features that you will leverage for specifically, like, let's say you've got a lot of kube clusters, and you want to be able to provide multi-tenancy for the control plane. We have something called admin partitions that enable that. If you want to be able to look at audit logs, for example, which is one of the principles we talked about for Zero Trust, that is an enterprise feature. So there's specific features that will help you scale out to address any organizational problems. And then on the Vault side, like we talked about in some of these questions, when you're using replication or DR, for the Vault clusters as well. Those are enterprise features built in the Vault product.
All right, we have a few more minutes. If you have any other questions, shoot them our way.
Yeah, good question about gossip key encryption rotation. So we investigated that piece on the engineering side, and what we found was that gossip encryption key, as it stands today, is not meant to be an automatic process. You'll notice if you look at our docs, there's actually a description of why that's not automatic, because at certain points in time after a new gossip key is issued, you still have some agents that exist that use the leverage the old gossip key, and they'll have to be notified about the new gossip key, and new agents that come in will also have to know about this new gossip key. So there's like a period in time where, you know, an operator will have to be intervene and make sure that the clients get the new rotated gossip keys. So at this moment, it's not automatically rotated, but we do store it in the Vault integration so that you can leverage that, and you can update it within Vault. Like once you do the Vault KV put to put that new gossip key, we can just pull it down and then use that for gossip rotation. The other thing to note is that within the actual gossip key, I'll just leave it at that. There's more documentation about how this works, but that's a good question.
All right, I think that's a wrap. But thank you all for joining. You can always reach us at HashiCorp channels. And I also want to thank our presenters, Blake and David, for demoing and going through all the content, and also the demo. And answering questions. Thank you all.